All right, everyone, this is the Hyperbola, lesson 9.2, day 1, centered at the origin. You should be watching this video after you have completed and taken notes on the Desmos. So just a little brief overview. We've got our two hyperbolas right here. This one has a horizontal transverse axis. That is the line that holds the vertex and the focus. And this one has a vertical transverse axis, one that holds the vertex and the focus. We are going to put a greater emphasis on our asymptotes here. Our asymptotes are kind of going to be our boundary lines. So we have two asymptote equations that you should have copied into your notes that I'm going to highlight when we do the problems. Just some key differences between the equation of an ellipse and a hyperbola. If you notice, the hyperbola has a minus, the ellipse has a plus. And another big thing is that the a squared is always positive. So if you notice, the b squared, if you look here, is negative, and if you look here, is negative. So the x squared and the y squared will change places, but the a squared is always positive. So that's like a little hint. I'll just type right here at the bottom, a squared is positive. So I'm going to just go over all the different parts of the hyperbola in standard form. Today, again, we're centered at 0, 0. So first thing we got here, again, this one is going to be our horizontal. That's going to be our horizontal. First, we have our center, 0, 0. Our transverse axis is going to lie on the x-axis. So it's going to lie on the x-axis. It's horizontal. Our vertices are going to be negative a, 0, and a, 0. Our foci are going to be negative c, 0, and c, 0. And our asymptote equation is going to be y equals plus or minus b over ax. It's just a simple rise over run. So that is for horizontal. Leave it there so you can pause it if you need. Now again, just note that the vertices and the foci are both on the x-axis here. See how it's a0, c0? So they lie on the x-axis. And again, the x squared is positive with the a squared. So over here we have the vertical. Now with the vertical, again, our center is 0, 0. We know it's in hyperbola because this is negative. We know it's vertical because the a squared is under the y squared, and it's positive. So our transverse axis is going to lie on the, you guessed it, y-axis this time. Our vertices are going to be 0, a, and 0, negative a. And now since our foci are on the same axis as our vertices, those are going to be 0, c, and 0, negative c. And our asymptote equations are going to be y equals plus or minus a over bx, and I'll explain that a little more later. This equation down here is for the foci. That helps you get the c value. Now, another key difference between the hyperbola and the ellipse. For the ellipse, it was a squared minus b squared. Now we have a squared plus b squared. So again, these are all opposite for the hyperbola. So now we're going to do the first problem. All right, so the first example that we're going to do, we have x squared over 16 minus y squared over 9 equals 1. So we checked that it said equal to 1, which it is. It's in standard form. There's a minus, so we know it is a hyperbola. So the first thing we do is got to figure out which one is a squared and which one is b squared. So since the 16 is positive, and again, I know it's positive because the 9 has the negative in front of it, that means a squared equals 16, b squared equals 9. So a equals 4, b equals 3. So what that means is the center is going to be a units away from the vertex. Now, since the x squared is first and it's positive, this is going to tell me it's going to be a horizontal hyperbola. So my transverse axis is going to be on the, I'm just going to write it here, transverse axis horizontal. So I'm going to use orange for the vertices. So my first vertice is going to be 4 units away from my center, which is at 0, 0. So again, I'll write that up here, center, 0, 0. So I'm 4 units away. So there and there. So my vertices are 4, 0 and negative 4, 0. Now I'm going to get my foci. So in order to get the foci, I'm going to use the equation c squared equals a squared plus b squared. C squared equals 16 plus 9. So c squared equals 25. So that means c equals 5. So I'm going to do the foci in purple. So now they're 5 units away from the center. So here's the center. You can see my hand's not in the way. 5 units away puts me here and here. So my foci are at 5, 0 and negative 5, 0. All right, so now we're going to what we call make a box. So the way we're going to make the box is going to go around the A values and the B values. So the B value is 3. So I'm going to put a little dash here at 3 up and 3 down. And now you're going to make a box all the way around through the A and the B. Now you're going to make your diagonal asymptotes. Your diagonal asymptote is going to be y equals plus or minus b over ax. So that's going to be y equals plus or minus b, which is 3, over 4x. So it should be rise over run, and it should go right through the corner of the box. So rise over run, up 3 over 4. It's like slope, right through the corner of the box. You're going to do that for every corner. And now I'll do it in this green here. Now you can shape the hyperbola using the box guidelines. So from the vertex here, like that, and like that, like that, and like that. So this is your vertice, foci, foci. Your asymptote equation is this. And there are your vertices and your foci. And that is how you graph the hyperbola. So again, you got to make this box as like a guideline, and then your asymptotes will go through the corners of the boxes. And that is the first example. All right, so the next problem we're going to do, y squared over 25 minus x squared over 16 equals 1. So again, it is in standard form, but it is going to be a vertical hyperbola. Now we know it's vertical because the a value is under the y squared, so that's going to tell us it's vertical. And if we reference back to our little diagram over here, we have it set up as vertical, or you could reference from the first slide with the picture here. So this is going to be all available for you on Google Classroom, like always, so that you can check. So our a squared is 25 because the a squared is always positive, so that makes our a 5. Our b squared is 16, so our b value is going to be 4. So our transverse axis here up on the top, if you can see that, is going to be the y-axis. So because it's vertical, my vertices, judging from the a value, are going to be 5 units away from the center. So my center is at 0, 0 for today. So there's my center at 0, 0. I'm going to use orange again. And I'm going to go 5 units up. So there, and then 5 units down. So those are my vertices. So my vertices are going to be 0, 5, and 0, negative. Oops, sorry, 4. And 0, negative 5. So now I got to get the foci. So the equation I use for the foci is c squared equals a squared plus b squared. So c squared equals 25 plus 16. C squared equals 41. So c equals root 41. So if you're not sure what to do with root 41, all you're going to do is type in root 41 in your calculators. So you're just going to grab your calculator. You're just going to do square root of 41. It's about 6.4, and you're just going to estimate. Remember, you're going up. So 6.4 is like here, and down 6.4 is like here. So there is a foci, and there's a foci. So your foci are going to be 0, comma, root 41, and 0, comma, negative root 41. Now we're going to make that box. So in order to make the box, we have to use the B value. The B value is 4. So the box is going to come out 4 units. And now you're just going to go from your A to your B, and you're going to make a little box that is 5 units high and 4 units wide. And this is going to help us with our asymptotes. So again, the 4 is from the B value. So there's the box. Now you're going to do that asymptote equation. Since it is vertical, your asymptote equation is y equals a over bx plus or minus. So that's going to be y equals 5 over 4x. And a good way to help you remember is it's got to go through the corner of the box. And it's rise over run. So you get a rise 5 and run 4. So that does it. You're going to do that in all the directions. I know the box seems tedious to make, but it does help us with the asymptote equations. Now you can just draw the hyperbola. So I'm going to do it in this red pen. And if you notice, I'm guided by the box and those asymptotes. And there's my hyperbola. I've got my equation. I've got my vertices. And I've got my foci. And that is the second example. All right, so next one here, I'm going to go through it a little quicker since I think we're starting to get the hang of it. But the first thing you should notice right away is it's not in standard form. Why is it not in standard form? Because it's not set equal to 1. So what do we do to make it set equal to 1? We have to divide everything by 36. 36, kind of the same way we did for ellipses. So this is going to become y squared over 4 minus x squared over 9 equals 1. So at this point in the video, I'd like you to pause it and try it on your own. And then you can check your work with me. So pause it and give it a shot. I'm going to start going over it. So your center is at 0, 0 again. I'm going to go through this one a little quicker. Your a squared is 4, so your a is 2. Your b squared is 9, so your b is 3. So that makes your vertices, are they going to be, is the transverse axis going to be horizontal or vertical? It's going to be vertical. And why? Because the a squared is under the y squared and it is positive. So it doesn't really matter that the 9 is bigger than the 4. That really doesn't work for hyperbolas here. What matters is that it's positive. So the a squared is always positive. So this is going to go, your vertices are going to be 0, 2 and 0, negative 2. So to be consistent, I'll do that in orange again. There it is. Now for your foci, we're going to do c squared equals a squared plus b squared. C squared equals, what do we got? 4 plus 9, so c squared equals 13. C equals root 13. So again, if you don't know what square root of 13 is, just type it in your calculator. Square root of 13 is 3.6, so I'll do that in blue. So you're going to go up about 3.6. Down about 3.6. So that makes your foci 0, root 13, 0, negative root 13. I'm off the page. All right, now I'm not off the page anymore. So there's your foci down there, 0, root 13, 0, negative root 13. So now we're going to make the box using the b value. The b value is 3. There's the box. This is not Roddy Rich's box. This is the hyperbola box. So now you're going to do your hyperbola equation. So this is y equals, it is a vertical hyperbola, so it's going to be a over bx plus or minus. So y equals a over b, 2 over 3 plus or minus x. We go up 2 over 3. And I'm going to go right through the corners. Now you can draw the hyperbola. I will do it in green, guided by the asymptote. So again, you have your asymptote equations, which are right here, your foci, which are here, your vertices, which are here. And that is example 2. Getting it in standard form, it's got to be equal to 1. And we got one more example to go. All right, the last one we have here is writing in standard form of the equation of the hyperbola with foci negative 90, 90, and vertices negative 60, 60. So the first thing I recommend doing is just drawing a little sketch of everything that you have. So your vertices, I'm going to do in green here. So they're going to be at about 6. Again, this is just a sketch, doesn't have to be perfect. There's 60. There's negative 60. Foci I'll do in red. They're out here at 9. So it's negative 90. There's 90. So since they are horizontal, that tells me that the x squared is going to be positive. So I'm going to write it out like this. Because the a squared is going to be positive, and that's going to go under the x squared. So it's going to be a horizontal hyperbola. It's going to look like that. But we need the equation. So the a value is the distance between the center and the vertices here. So your a is going to be 6. So if a equals 6, a squared is 36. So 36 is going to go under here. Now, we don't know b squared, but what we do know is we know c. So if c equals 9, c squared is 81. So that tells me c squared equals a squared plus b squared. 81 equals 36 plus b squared. So that makes b squared 45. So 45 is going to go right there. Your equation's done. So after you finish watching this video on Edpuzzle, you're going to do the 3 problems from the lesson directions and turn it into this post. If you have any questions, email me.